So, on the news, we hear a lot about greenhouse gases and climate change. And we just want to go through and give you a little more information about what's fact and fiction and what has been caused by man and what things are just going to happen just regularly in nature. So, here we go. So the greenhouse effect is a natural process. It causes a warming of the atmosphere by by the trapping of infrared radiation, which we feel as heat, by certain gases that are called greenhouse gases. Examples of these gases include carbon dioxide, methane, that's CH4, and nitrogen dioxide. And there's a lot of nitrogen oxides that count in this area, as well as some different others. So down the bottom, we have a picture of this. And so the reason they call it greenhouse gases is it kind of acts like a greenhouse glass. So there was an old episode of Frosty the Snowman where he and a little girl are heading back up to the North Pole so Frosty won't melt. And the little girl gets really cold. And so they stop and they step into this greenhouse, and then the evil magician dude locks them in. And the greenhouse stays really warm. So even though it wasn't heated, what it does is it allows the infrared radiation to come in from the sun. And then the glass traps that heat inside. That is a greenhouse effect. Well, what happens with our atmosphere is that the atmosphere, certain gases in the atmosphere, allow that radiation to come in, but then it traps it inside. It won't allow that radiation to like bounce off the surface and escape. It traps it inside. And the more of these greenhouse gases that we have in our atmosphere, the more of an effect that we will have. Now, the greenhouse effect is a natural effect, and we have to have some of these greenhouse gases to keep the surface of our planet approximately the same temperature. If we didn't have enough, we would have extreme hot and cold, whether it be day or night, and that would be very bad for people. That's why there's a lot of planets we can't even think about inhabiting because they don't have any greenhouse gases. Too much greenhouse gases causes a different problem. Too much greenhouse gases are going to trap in too much of this heat, and the temperatures are going to rise. So it is a natural process. It is a necessary process. However, man has caused some additional gases to be released, more than what we should have, and we're going to have to see if that's going to change the climate, as we're going to find out on the next couple slides. So all of these gases you will find even if man never existed in nature. But right now, a couple of them are under fire. So carbon dioxide, they've talked about the increase of carbon dioxide due to the burning of fossil fuels. Are we burning too many fossil fuels and releasing too much carbon dioxide? Methane, right now, one of the big things is beef production and how cattle will release methane when they chew their cud, and so is having cattle causing global warming. Okay, some of this goes a little too far, but there is an effect. So let's dive a little bit more into this. Now, like I said, you have to have a certain amount of greenhouse gases. You have to have a certain way to regulate the temperature on the surface of a planet. So the atmosphere is needed to regulate temperatures. You have to have a certain amount of greenhouse gases. Down on the bottom, I have 3 pictures of different planets. The first is Venus. Venus has a very, very thick atmosphere. It has many, many, many more greenhouse gases. And so it's trapped so much of the heat by the surface of the planet. It's very, very hot, almost a molten surface. We couldn't survive on that one. The pressure is also like astronomical there. It's kind of crazy. The middle picture, well, that's good old Earth. If you've watched the Simpsons movie, they have a picture almost identical to that of Alaska. We have some greenhouse gases, but not too much. It's kind of like the Goldilocks and the Three Bears. It's not too much, it's not too little, it's just right. The picture on the right is of Mars. Mars has a very, very thin atmosphere. So maybe if you've watched The Martian, no, we've never actually been to, the humans have not actually been to Mars yet. We sent rovers. But the movie does portray some things kind of interesting at the very end when Matt Damon is trying to leave Mars to catch the ship to go home. They talk about how little air resistance there would be. It has less air molecules. There's less greenhouse gases. It has less of an atmosphere. It has less of greenhouse effect. What that would mean is that the side facing the sun and the side of the planet away from the sun are going to have very, very drastic temperature differences because you can't trap that heat in there. So that would make it to where at this point it's not livable for us without a lot of protection. We need something to help regulate those temperatures. So this particular slide is going to switch up the planets just a little bit. We're looking at Mercury, Venus, and Earth, the three closest planets to the sun. And you'll find out that Venus is actually hotter temperatures. The temperature on Venus is actually above the melting point of lead because it has really, really thick clouds and lots of greenhouse gases. And so the temperature on both sides of that planet are really, really hot. If you look at Mercury, even though it's closer to the sun, you see this wide range in temperatures on which side of the planet you're on. And it's still even the side that's closest to the sun, and it's a lot closer to the sun distance-wise than Venus. Even that side doesn't get as hot or as high of a temperature as it is on Venus because Mercury doesn't have the greenhouse gases. And then we have good old Earth, which again is kind of in between, not too much, not too little. It's just right for human life. Okay, so we've established the fact that we have to have greenhouse gases. The greenhouse effect is what keeps our planet in a livable format. But can you have too many greenhouse gases? Can man affect how many greenhouse gases there are and have a negative effect on our environment? Well, to study this, what they've done is they've tried to look at the rise of carbon dioxide levels over the years. So down at the bottom, we have a chart that goes over from 400,000 years ago till today. And you might say, wait a second, how do you know what happened 400,000 years ago? You know, it's not like men had computers writing down the temperatures. Well, what they do is they can take core samples in glaciers, and based on the amount of carbon dioxide that's been absorbed in those certain areas, or based on the plant life that they find at different core depths, we can estimate the amount of carbon dioxide that was in the atmosphere. And what you'll find is that there are rises and there are falls, and you can track it with temperatures. There's high temperatures and there's low temperatures. And that has happened in a cyclic format since the beginning of time. But ever since the mid-18th century, the mid-1700s, the amount of carbon dioxide has been rising drastically. Now, a lot of times people will point to the Industrial Revolution as the beginning cause of this. So the Industrial Revolution was whenever factories came into big play, where people were no longer on farms just trying to survive and having little trades. They would send people to factories, and then the factories would work the people and make large quantities of whatever it is that they have. Well, those large factories weren't worried about the environment. They didn't know to be worried about the environment. They would burn lots of fossil fuels that were being released into the atmosphere. Lots and lots of fossil fuels. Today, the amount of carbon dioxide in the atmosphere is about 40% higher than pre-industrial levels. So this isn't within that normal cyclic variation. it's a lot more than what it probably should have. And it's growing at about 0.5% per year. So it's still growing. So we can point to this idea of the rise of carbon dioxide levels as being an anthropogenic activity. That's a good word, isn't it? Anthropogenic. Anthropogenic. Activity. And that just means that it's by man. Man is a cause. It's produced by human activity throughout time. So we see this rise in carbon dioxide levels. What effect will that have? Well, we know that human activity has increased the amount of carbon dioxide that seems to be in our atmosphere. And we need to know if that rise in carbon dioxide is going to be enough to change the amount of the greenhouse effect, and can it change our climate? What we're worried about is a rise of temperature. That's what we've been trying to track. And we have seen that there's been a rise of about 2 to 4 degrees per century. Now, over time again, just like the rise and fall of carbon dioxide levels, you'll see a rise and fall of temperature. And it'll stay within kind of this normal range. But what we're concerned about is that it's growing too fast and it doesn't seem to be going the other way. There's still going to be variations, but we're getting further and further away from the baseline or the average from many, many, many years ago. Now, if there is a rise in temperature, you'll see a rise in the ocean levels. So the glaciers will melt and it will cause higher ocean levels. And then that can also cause a lot of problems, declining glaciers, all sorts of stuff. You'll see changes in growing seasons. There'll be earlier growing seasons and also migrations of animals and plants. And I've actually seen that migration of animals, especially plants a little bit, not too much. I'm not really a plant person, but animals. Whenever I was a kid, I went with my dad. We had a hog farm. So we went to Oklahoma City to get these hogs, and I saw my first armadillo on the side of the road. Now, I went all the way through, elementary and high school, only seeing these armadillos when we go visit Oklahoma somewhere, where we drive far away. I moved away to go to college, and many years later, I came back to the southeast Kansas area. And by golly, we had armadillos here. I didn't know what to think about these things. Heck, I even had one living in my backyard earlier this year. Luckily, I think it's gone now, but we didn't used to have them. And could the fact that we have armadillos now be a result of this whole climate change? Is man doing just this horrible effect on the earth, and what can we do about it? Well, different politicians have gotten together, different countries have gotten together, different governments, and they've talked about some ways that we can help control this, where we can help limit it or make it better. One thing that they've talked about are economic incentives. There we go. We have carbon taxes, and carbon taxes, what they do is after the fact, they would go back to a company and they'd say, okay, you released this much carbon into the atmosphere, we're going to tax you X amount. So the more industry that you have, the more that you burn fossil fuels, the more we're going to tax you at the end. Cap and trade, what that is that it kind of goes the opposite way. So before the fact, a company would buy permits to be able to release a certain amount of carbon dioxide. And if they didn't release that much, they could actually sell or trade those permits with other companies. So they could sell the unused ones. The Kyoto Protocol down at the bottom, this was a treaty back in 1997 to help industrialized countries set target goals. So we want to try to reduce the amount of carbon dioxide that's being released. So let's set some goals for different companies in different countries to meet. All right, so quick little question for you. The evidence of global warming can be obtained through measure a day's temperature, a year's temperature, the year of ice depths in the Arctic, or decades of ice depths in the Arctic. Whew. So on this one day's temperature is not enough to tell you much. Even a year's worth of temperature isn't enough to really tell you a lot. What's going to give you a lot more information is if you measure over a long period of time. So we need the decades of ice depths because the depth of the ice is related to the temperature in the Arctic.